Hi, this is Mr. Word. I'm going to talk about some of the problems in 10.3 that we're working on. The first few are really simple. It's just like make sure you understand what these things are. So we want to match each item in the left column with its correct name from the right column. This is just to confirm that we know what we're talking about. So we're looking for the radius, and RP could be a radius. And QP could be a radius, and PS could be a radius. So let's see if we've got a radius. So PS, so segment PS would be A. So A there, that's a radius. So check, we've got a radius. And then also RP and QP, those are all radii. Let's find arc QRS. Since it's got three letters, that means it's a major arc. So that is going to be E. That's a major arc. That's going to be QRS. Okay, so it's going to be the arc that includes QRS. It looks like that's actually a semicircle, though. So we could call that the major arc, but since it's only half of the circle, we're going to actually say F, semicircle. That one's a little bit of a trap. And then segment QS is the diameter. So that's the diameter. Okay, so let's check off semicircle and diameter. And then we've got a three-letter arc here, so that could be a major arc. So let's consider that's RQS. So arc RS is the minor arc. Arc RQS is the major arc that's more than 180 degrees. So that's E, major arc. Okay, so cool. Then we have arc RS, which is just this part right here between R and S. That's the minor arc, or D. Okay, so check that off. RS connects the endpoints of an arc. That's a chord. So that's C. Okay, so the chord is segment RS. And then there's another chord, QS. That's the diameter chord. And then angle RPQ is a central angle. So that's the central angle, or G. Okay. All right, let's look at number 2. So we need to name the major arc of the smaller circle. Name a major arc of the smaller circle. Well, that would be QPR. So I'm going to go ahead and write that in here. So that's going to be QPR. Okay, and we'll put a little arc symbol over it. It's 3 letters because we need to include. I'm sorry, did that backwards. That should be QRP. Actually, QRP or QPR, both of those work. So those would both be major arcs. So QPR and also QRP. All right, a minor arc of the larger circle. That could be AB or it could be BC. So you could say AB like that. You'll be able to do this much faster by hand than I can with this computer. So that's AB or BC. You put the little curve over it. Name what is the measure of arc BC and arc PQ? Well, those measures, those two arcs contain a combination of two angles that make 180 degrees. So that would be 180 degrees because the central angle combined for both of those, even though they're on different circles, comes out to 180 degrees. So 180 for that one. 180. Okay, and then degrees. And then which is greater, arc BC or arc PQ? The measure of arc PQ is going to be greater in degrees because it is more than 90 degrees, where there is, and so it's obtuse. And BC is acute, it's less than 90 degrees. So we would say PQ is greater. And then is arc BC congruent to arc QR? They are not, because they are not arcs of congruent circles. So they have the same measure in degrees, but they're not the same distance from a center of the circle. So no on that one. Okay, we will pause. So number 3, we have circle E, and we're supposed to find each of the following. So the measure of arc BC. So let's look at arc BC. And you see here it's got the little right angle symbol. So that's 90 degrees. Okay, so that one, arc BC is 90 degrees. Okay. Then we've got the measure of arc AD. So AD, okay, well, the way you'd figure that out is notice that BD is the diameter. And so B through D is going to be 180. We've got the measure of arc BA from the central angle being 50 degrees. So this angle here is going to be 180 minus 50, so that's 130. So 130 degrees for arc AD. Now let's look at arc ACD. So ACD is going to go all the way around the other way. Arc ACD is going to be 360 minus 130. So that's going to be 230. So 230 degrees from here all the way around. That was a terrible drawing. So let's try that again. All the way around. That was also terrible, but I'm going to leave it. So that is 230. 230 degrees, because that's 360 minus 130. Then major arc BAD, but that's not a major arc, that's a semicircle. So that one is 180. So that's 180. I do very much hate this drawing tool. Okay, and then finally the measure of arc ADC. So that's a major arc, and that we know that the central angle for arc CD is 90 because of the 90-degree mark there. So arc CD is 90, and we've got the measure of arc AD, and arc ADC is made up of both of those. So 130 plus 90 is going to be 220. So this arc here is 220. All right, let's take a look at the next one. Drag the page up a little bit. So 4 and 5. So 4 and 5 start to get into a little more serious geometry beyond just identifying things. We've got circle Q, which means Q is the center of the circle. And we know that angle A is 25 degrees. Well, and we want to find the measure of arc AB. So to do that, we need to find the measure of angle AQB. All right, so let's see what we know. We know that AQ and BQ are radii, so they're the same, which means that angle A and angle B are both the same. So they're both 25 degrees. So 25 plus 25 is 50. The measure of arc AB is going to be what's left of a triangle, which will be 180 minus 50. Okay, 180 minus 50 is going to be 130. So the measure of that arc is 130. Okay, because the measure of the angle, the central angle, is 130. So that is 130 degrees. Now we'll take a look at this one. We've got circle P. So P is the center. And we're told that WY arc WY is going to be the same measure as XZ. So I'm going to draw those here. So this is arc WY, and we also know that XZ, I'm using the same color to indicate they're congruent, that those two arcs are congruent. And what we want to prove is WX, is WX congruent to YZ? Well, if these two arcs are congruent, one thing we know is that, well, we know that WPZ and WZ is a diameter, so it goes through, because it goes to the center. So that means that arc WXZ is 180 degrees. Okay, so that tells me that arc WX, so we're going to first need to figure out arcs, because these are going to be, WX is a chord. So we're going to try and prove, is the arc WX congruent to the arc YZ? Now, I've just given you a hint on that. I encourage you to pause this one and see if you can figure this out. And assuming you paused and you're back, what we can say is that the arc WX is supplementary to the arc XZ, and the arc YZ is supplementary to the arc WY, because combined they make 180 degrees. So we have two arcs that are supplementary to congruent arcs, and supplementary things to congruent things are going to be congruent. I mean, we know this about angles. The same will be true with arcs. So because those two arcs are supplementary to congruent arcs, WX, arc WX and arc YZ are going to be congruent. And because the arcs are congruent, the chords are congruent, because if you have chords that are formed from the endpoints of congruent arcs, will also be congruent. So hopefully that clarifies how you would approach that. I'm going to stop this video and then make another one about some of the more challenging problems.